Okay, good. Just wait for a while, yeah. I wait for others to join the group. Can you see my PowerPoint slide, chapter 5, about the electrical drive system? Okay, so now we have 34 in our meeting room. So we total having 88 number of the students in the class. So we just wait for a while for others to join. So today I will discuss about the motor drive, basically to explain to you about how to develop the control circuit to drive the different kind of motor. So we have the AC motor, we have the DC motor, and also synchronous motor and so on. Okay, how we're going to control the speed of this kind of motor using the power electronic converter circuit. Now we have 38, 39 students joining the group. Okay, hopefully today we can hit about at least of 50 to 60 students. Total we have 88 students in the class. Okay, before I start the class, let me give you some latest information about the announcement made by the Utah top management. Okay, so due to the COVID-19, so the university has decided to cancel off all the final exam. Okay, that means there will be no final exam. Can you hear me? Everyone can hear me?
Yes.
Okay, just reply to the message. you have to mute your mic, otherwise there'll be a lot of echo from one to another. Okay, based on the announcement made by the top management, there will be no more final exam, and then it will be replaced by the so-called the final assessment. Okay, final assessment. So the form of the final assessment has to be decided later on. Okay, the final assessment may be in terms of another individual assignment or other form of assessment. Okay, and the total mark is will be reduced based on the latest format that we got so far. Your coursework will contribute to total of 60%. Okay, remember, your coursework now initially was 40%. Now your coursework become 60%. Okay, your coursework becomes 60%. That means the mark for the midterm test rise to 30 marks, from 20 to 30, and then your assignment from 10 to 15, and then for lab also from 10 to 15. In this applied to all the subjects, okay. It happened to all. That means there will be no final exam at all. Everything will be assessed through the online. So this time you have to work in different way, okay. I may conduct a different kind of assessment, okay. Maybe some individual assessment within the certain time limit. You have to submit your result and so on. Okay, so this is the best we can do, but we need to work on this under this condition. Okay, the second one is that the study week will be delayed by 2 weeks. That means next week will be week 10, so-called the new week 10. Okay, the new week 10. That means the previous 2 weeks are not counted. So the next week will be the week 10, then week 11, week 12, and week 13. So that means your final assignment submission will follow the new week 12. Okay, follow the new week 12. That means if you follow the old one, will be week 14 already. So you have more time to prepare your assignment. So try to make it better. So because the mark is higher. So for midterm test, because the test is over, so we have to have a mark more lenient now this time, okay, so that it will not penalize you all, okay. And then for the assignment, try to work, okay, in your teammate using the online method, through the video conferencing, WhatsApp, whatever. And then at the end of the project, you have to record the 5 minutes video and upload, okay, together with the report in one folder. That means you put one folder, your team, okay. Then maybe just put a team leader name, and then inside there are team member inside the report. Then attach together with the video recording. Okay, that show your simulations, show your whatever possible hardware that you have. Show that you're working as a team. Okay, so this is about the assignment. For the lab, okay, so I think I already uploaded the so-called the pre-result. Actually, the result that I obtained from my own experiment some time ago. So you can use that result to prepare your lab report. The submission will still follow. Okay, will follow the new weeks. That means if they say you have a lab in this week, then you have to submit your lab report by next week. So this one we call it a virtual lab. Okay, but actually lab 2 can be very simple because you only need to do the part 1 of the lab 2. where the part 2 is only consists of one very simple pulse generator. Okay, so my result of that I put in the online actually are the result from the part 1. The part 2 no need to do, but you just need to explain and attach inside your lab report. Okay. So you say some of my parts are different member hand. So you have to figure out how to work on your assignment. Okay. What do you mean by assignment update in Weber? Okay, to make it simple, I will upload the new submission deadline for the assignment. So if you want to follow the old system, that means will be the week 14. Okay, if you follow the new week, because the next week will be the new week 10. We call it new week 10 because the past 2 weeks was not counted. Okay, it's under the MCO. So this is by the management. So that means you can submit your assignment by new week 12 or old week 14. Okay. Midterm test you did badly. This one, we will try to figure out. Okay, so you try to do well in your assignment and the lab. Okay, because the mark is all checked out by I think it's 0.5. I think. So that means if your midterm test is maximum 20 marks, then now become 30 marks. If your lab is 10 marks, now become 15 marks. Assignment, 10 marks become 15 marks. So that your final exam, final assessment will only contribute 40%. Okay. So this 40% will also be a different kind of sort of not non-face-to-face assessment also. There may be another so-called individual assignment to you within the certain time frame. Okay, so if possible, do not wait. Okay, do not wait until the last minute because I believe it happened to be all the subject. At the last minute, when the final assessment start, you will be getting crazy busy. Okay, just to let you to be aware of this one first, because the faculty will tell us, okay, within week 15 to week 16, you have to carry out all your final assessment. We don't call final exam anymore, right? We call final assessment, which contribute 40%. So within this time period, you have to complete certain tasks. Okay, maybe 2 or 3 tasks. Not only for my subject, but also other subjects taken by you at the same time. Okay, so the final assessment, how to carry out this one, we are still they haven't come up with a final guideline from the faculty or from the university, but it may consist of like an individual assignment or like a individual short question kind of things that need you to submit within certain time period. Okay, so not only happened to Utah actually considered very lenient already. Other university is getting even worse. So you don't. This happened to everybody in the world now, not only the Malaysia. Okay, not only in our Utah, not only in our Malaysia university. All university, all around the world happen to be the same. Okay, so we have to try to work hard on this one. So total is 40% for the final assessment. Okay. So it also affect the next semester also. So I don't know. It depends on how the situation of this COVID-19. We hopefully that the thing can get better. Okay. A lot of things that we are out of control. Everybody has to be quarantined at home until 14th of April. Not even to step out from the house. Okay. Even my opposite is the playground. I still cannot go there. Okay. Otherwise the police will chase me home. They say nak kena saman tak? Kalau tidak cepat balik rumah. So like this. So we all need to stay at home. until 14th of April, no choice. But the thing have to be carried on. Okay, so that's why we come up with the final assessment. I hope you all okay with this. Okay, it happened to all the subject. So please start to work on your assignment and the lab or whatever that is pending and submit as completely as soon as possible so that you have a more backup time, okay, to deal with your final assessment. Okay, it will happen at the last minute, and also all the subject may be together like a final exam. That time will be very cheeky okay, very cheeky to tell you. This is the first time. A lot of things will be kelam kabut for sure, but we will follow the proper procedure or guideline given. Okay. Okay. So by this, I will continue my discussion on the next chapter. Okay. So this chapter is about the electrical drive system. So this, what you mean by electrical drive system here, is actually about the driver that used to drive the motor. Okay, the driver. Okay, as you know, right, when you buy the graphic card, you buy a lot of those different kind of the modem, you need to install the driver. So driver actually is a medium that handle the energy, the signal to the motor, to your graphic card to do their job. Okay, this is what we call a driver. So in this chapter, we're going to develop the driver for the different kind of motor system. We have the AC motor, we have a DC motor, and so on. Yeah, so this is what we are going to focus on this chapter. And the main focus is not on the study the motor behavior only, but we need to study the driver, the drive system. Okay, different kind of systems such as the semi-converter, full bridge converter, half bridge converter, and so on. How actually we can control the fire angle, how we can control the duty cycle to control the motor speed, motor torque, and kind of things. So this is the objective for this chapter 5. Okay, one more thing is that I updated some of the information in chapter 5, so which I already uploaded in online web. Okay, please get the latest version. So I only updated those their theory part to make it more clear and more specific. Okay, the formula, the calculation part remain the same. Okay, so let's take a look. I already shared the screen. Can you see my PowerPoint or not? Just wonder. Okay. If I click to this screen, okay, now I already showing the PowerPoint for chapter 5, electrical drive system. Are you able to see the PowerPoint? Just to ensure that you can see it, because I want to use the pointer function in the share window. I cannot use the function of the pointer, so I need to I can use the pointer in the share desktop. So that's why. Okay, you let me know, see whether you can see my PowerPoint. Can confirm PowerPoint can Okay, now I switch to PowerPoint now.
Oh.
Okay, so I will use the pointer. Okay, I will try a few things first. Okay, I will try to sketch something. Okay, now I circle on the chapter 5, electrical drive system, and also my name, and also my background. Okay, so are you able to see the thing I wrote here? Okay, can you tell me what is the words I write on the PowerPoint to confirm that you know how you see what I do on the. Okay, good. Okay,
That's very good, very good. Okay. If you can see, that means you can see what I did on my screen. Okay. Right. You can see me. So later we can try to do some guessing job. Okay. All right. So now I continue. Okay. So this is a new slide. You don't need to follow your old slide. Okay. But not much of different. Only some changes, update information on your PowerPoint. Okay, on your theoretical part. Okay, first you need to understand the difference between the generator and motor. Okay, why sometimes the people call this as a generator, but sometimes this people call as a motor. Okay, actually these two things are referring to the same mechanism and the same design. The difference is that the motor is that I supply the electricity to the motor so that the motor can turn and do their job. So now they work as a motor. But then, in the other words, if I set up in the motor, right, I supply the power to the rotor. Rotor means the outside one to turn, okay, to turn the rotor in the inside one. For the if they work as a generator means I turn the rotor. So the rotor is turning, they will induce the voltage to your stator. Then this one we call as a generator. So normally in the power plant, okay, in the coal-fired generator, okay, normally they will use the generator to generate the power. But in the EV, electric vehicle, the compressor, all those water pump, they use the motor. Okay, motor is to do the work. Generator is the mechanism to generate the power. Okay, I hope you with this. Okay. Okay. All right. So this slide show you the electric motor family. So in general, I classified the motor into the AC motor family and the DC motor family. And the DC motor can be the brush and the brushless. The brush means I've used the carbon as a medium, as a commutator to supply the power to the winding. Use a brush as a medium. For the brushless, they will use the Hall effect sensor. So it's a contactless method. Okay. Then for the AC motor, we have a synchronous motor and induction motor in general. Induction motor actually is referred to the asynchronous motor. Asynchronous motor means they will not work at the synchronous speed. That means the speed different, the speed between the rotor and stator are different. But for the case of synchronous motor, the speed between the rotor and the stator must be very, very close, must be more than 95%. That's why we call it as a synchronous motor. They have to work at the same rotating speed. Okay. Then under the rest of it, they were actually not so important. Okay. So for the DC motor itself, right, it can have the more specific one is referred to the PMDC, permanent magnet DC motor, which I've used the magnet to generate the flux so that it can react with the armature to generate the rotating force. Okay, and also there will be a separately excited, okay, the DC motor. Okay, that means I replace the magnet with the external winding to generate the flexible flux so that I can control the torque, I can control the speed externally. Then the self-excited is another kind of the DC motor as well. But in this chapter, I will focus on the PM, permanent magnet DC motor, and the separately excited DC motor only. Okay, so in this chapter 5, we have two parts in the chapter 5. The first part is dealing with about the criteria for selecting the drive component. Let's say you want to to develop the conveyor system, for example, okay, to carry some load on your conveyor. So you need to choose what is the specification of your motor to be choose, what is the driver to be choose, the motor drive system to be choose, so that it can work accordingly, so that you will not overload or underload your motor system. Okay, so this is to optimum mesh between the mechanical load and the drive component. So later on, we also need to study about the DC motor drive, right? DC motor drive, such as we have the semi-converter, okay, full pitch converter, a dual converter, and so on, which is different way to drive the motor. In the part 2, we are going to study about the AC motor. Okay, AC motor can be classified into the synchronous motor and induction motor. Okay, I'll focus on these two. All right. So in general, the motor drive are used from few watts up to the 1,000 kilowatts. It can be very heavy duty, such as the one that used in the heavy industry. For example, our Proton, okay, our Perodua, right? Their molding machine, right, actually are driven by the very heavy, very powerful induction motor actually. Because when they want to compress on the metal plate, right, they need to produce a very high torque. So this torque must be high enough, can be go up to 1,000 kilowatts. So you need to have a good driver that can withstand this kind of the power trend, high current. Okay. Okay. When you come to the motor, right, I want to make one very clear statement is that when you deal with the motor, okay, regardless of AC motor or DC motor, the torque, okay, torque is proportional to the current. This will be the keyword. Okay, the torque is proportional to the current. Torque means the force to do the job, to carry the job, the force. Okay, so if I want to increase the torque to carry the heavy load, then I will need to increase the current so that it can obtain more energy to do the job. But then, if I want to increase the speed is proportional to the voltage. So this
Uh, Sir, we cannot hear you.
Hello? Hello?
Ơi, sir, cannot hear you leh, ơi.
Sir, we can't hear you.
Oops. Eventually, I forgot to turn on my mic. I am so sorry. Just I think something already been missing out.
So not your fault. Somebody mute you, not your fault.
So okay. So you cannot hear anything from my previous explanation? Do I need to repeat?
Yes, you need to repeat.
Okay, good. Okay, so let me explain about the motor behavior. I come back to the okay, before I continue, please be cooperative. So because in this meeting room, everybody is said to be equal. You can remove me, I can remove you. You can mute me, I can mute you. So you don't touch my mic. If you mute my mic, then definitely you will disturb the process. Okay, so everybody has the same authority here. Okay, that's why you can see someone will remove me, someone remove you, kind of things. Okay, so please be cooperative, and then so that we can have a smooth lecture here. Okay, let me continue from this slide again. Okay, when you come to the motor, right? Okay, no matter for whatever kind of motor, I want you to make it very clear is that if you want to control the motor speed, you need to increase the voltage. Okay, because the speed is proportional to the supply voltage. That's why even when you work on the assignment, work on the lab, right? If you just plug in your power supply into your motor, right? If you increase the voltage, you see the speed will increase proportionally. It will increase very fast. That's why the speed is controlled by the voltage. But the current is different. Current is something that can do the job. So that means current is the one that controls the torque. So in other words, if you want to increase the torque of your motor, you need to increase the voltage. You need to increase the current supply of your drive system. Okay, so as mentioned just now, all drives, it doesn't matter for AC motor or DC motor, require the power electronic converter as an interface between the input power and the motor. That means we can control the requirement or the demand at the motor side by controlling the fire angle or by controlling the PWM. Okay. Right. So you can see from here, this gives you the better illustration about the application of the motor. Right. So here the motor. Of course, the motor, the aim of the motor is to drive the load. Okay, it can be drive the bell on the conveyor, or it can be used to like a drilling machine. You drill on the wall, so actually the wall, the drill bit actually is referred to a load. Okay, so now, yeah, this system, right, is more like your control system. If you are taking the next trimester subject, so-called control system, then you will be very familiar about this kind of the system. Okay, we call it as a closed loop system. The controller basically is like a summing amplifier, summing point that receive the input command or input signal, then they will compare with the feedback. The feedback can be the speed, can be the position, can be the acceleration feedback system by using the tachometer or or speed sensor to feed back into this controller. Then this controller will come up with the so-called error signal. So this error signal will give the proper PWM signal to the PWM to the power electronic converter. Then the power electronic converter will produce the sufficient power to the motor. So to make it very, very simple, right? Power electronic converter can be as simple as like a relay, one piece of relay. The signal from the controller is a small power to turn on the relay so that the main power can drive on the motor. So that can be, the concept can be very clear. Okay, but the relay, of course, they cannot control the amount of the energy being supplied to the motor. But the power electronic converter can, because we can control the duty cycle, we can control the PWM. Okay, so when you have then motor will work, motor will do the job. Then at the output side, normally there will be an output sensor. Okay, the output sensor can be the speed sensor, can be the position sensor. Okay, normally they will use like a tachometer, okay, to sense the speed. Then they will convert the speed back into the voltage or current to compare with the controller. Then the process will continue to regulate your output speed and also the position. Okay. Then the second example is more practically about the aircon system. Yeah, like your house aircon, right? So first, they need to sense your outside room temperature. Okay, so they will have the temperature and the humidity sensor. So they will sense sensor, then they will send back to the controller like a summing point. Then they will compare with the input signal and also your reference input through the summing point. Actually, this is a so-called summing point or summing amplifier. Then from here, they will generate the required output signal to drive the power converter. So basically here is like a pulse control. They generate the pulse, high and low, and kind of pulse. When the pulse is high, then your converter will turn on. Then energy will supply to the motor. Okay, then the motor will blow the the indoor blower. Then the fan will turn to cool down the room. Then the sensor will regulate the required temperature that you wish. Okay, so this is basically how the controller works. Okay, any problem so far? You can type in the message here. I will refer your message. Oh, looks like you have a lot of enemy. Okay. Chi Jun and Sereni, you got a lot of enemy here. So the other people keep removing you because you are not friendly here. Maybe, I don't know. Okay. So, by the way, okay, for others, please don't remove other people. Okay, this is highly prohibited. Okay, don't remove people. To be fair, you want to score well in the exam, other people also want to score well in the exam. So we fight fairly. Okay, we are gentlemen. Okay, we fight fairly. All right. All right. So I will continue. So it looks like my mic is working well. I think it's working well. You see my face, right? Naked face. Not naked actually. Don't worry. Okay. So in general, you need to understand the general behavior of the DC motor. Yeah? DC motor now are getting very popular in low power application, okay, but not in high power application. The reason is that the DC motor are not efficient, not high cost if you're dealing with high power, because the initial investment could be very high because the material cost, the design is bulky, kind of things, and also very noisy and dirty. Okay, let's take a look. For the DC motor, right, easy to speed control at a wide range. For example, right, even though your DC motor is designed to work at 1000 RPM, actually you can push your DC motor up to the about 200% of the rated speed. Okay, this one called this because they have a wide range of the speed control. So this is a good thing for the DC motor. They have a precise and easy to control at the even at the low speed. This one cannot be happen in the AC motor. Okay, and also they have a very fast, quick starting and the stopping. Okay, for the DC motor, high starting torque, yeah, especially at the low speed. So they have a high starting torque and simple, cheap drive design. To say cheap, actually not really cheap, but compared to the AC, is much simpler and cheaper. Yeah, because AC motor are more complicated to control the speed. You need to control the frequency by using the variable speed drive and so on, which is more complicated. But DC is more straightforward. You can just simply use the rectifier, okay, the DC rectifier to control the speed by controlling the fire angle. Okay, so they have an efficiency of from up to like 85 to 95%, which is very good nowadays. That's why you can see a lot of the small power DC motor being used in our desktop PC, for example, right? You see those cooling fan lah, the CPU fan lah, or those microprocessor fan lah, this kind of fan, right? Your GPU fan, all those driven by the DC motor. Okay, because they have a very high efficiency and have a good torque at the low speed, especially, and also easy to control. That's why they are very popular in low power application, but not in high power. High power definitely must go for the AC motor. Okay. Another one is that there are no harmonic effect on the DC motor. No harmonic is because we do not deal with much of the switching. We don't switch on off very often. Okay, so it's just like a simple rectifier. So they don't carry much of the harmonic, okay, compared to the AC motor. But then they still experience some disadvantages, such as high initial cost. You know, right? Even the permanent magnet DC motor, right? The magnet itself could be quite expensive also. Yeah, the magnet, especially those high intensity, okay, high power magnet, it could be very expensive also. Okay? That's why they say they have a high initial cost. Physically is larger, yeah, because they need to have the carbon brush as a contactor. They need to have a commutator. Sometimes they need to have a slip ring, okay, and so on. So it makes the size become larger compared to the AC motor. Okay, and high maintenance due to the commutator and the brush. Yeah, high maintenance is because it contains the brush inside. The carbon brush is very soft one, tell you. Okay, for example, if you on the water heater right at home, right? If your water heater is a kind of like a water pump water heater, if you open up the water heater after 1 or 2 years, you will notice that inside can be very rusty and very dirty because the brush is already been wear and tear. So if your water heater suddenly one day it doesn't work, then it might be due to the brush, the carbon brush being wear off. Then you need to replace the carbon brush. Okay, and also there's dust because of the brush, and not in the hazardous area. This one is very important. Yeah, we are not encouraged to, not so encouraged. We are prohibited to use the DC motor in the hazardous area, such as in the oil and gas industry, refinery, oil industry, for example, the chemical process industry. The reason is that because when you have a brush, the carbon brush, right, as a contactor inside the motor, when the motor is running, it will generate the spark. You see the sound, right, is very noisy. Zzz, it's very noisy. They will generate the spark. So this spark may cause explosion in the hazardous area. That's why in the hazardous area, we don't implement the DC motor. Only the AC motor is allowed, because AC motor no contact between the rotor and stator. Okay, so I got a lot of video to show you about my own working experience about repairing and kind of things, but here I try to show you the video, see whether you can see some of my work or not. Yeah, you're true. For those PC fan, we use brushless motor. Okay, for those more the application required clean environment, we need to use the brushless motor. Okay, if you use the brushless motor, then you will not have this dirty or rusting issue lah. Okay, so that's why in your PC the CPU fan is really as a brushless PC motor. Okay, I think I cannot show you. I have no video to show you here. I think I have to upload first, but never mind. I'll do it later on. Okay. So in general, for AC motor, in general, we only have two family. Okay, one is synchronous motor that running at the synchronous speed between the rotor and the stator. The second one is induction motor, the general AC motor. Actually, the one that you use in the exhaust fan, the ceiling fan, table fan, the compressor fan, all those kind of fan, right, actually are referring to the AC induction motor. Okay, AC induction motor, where the speed and the position are not so critical. Okay, but then for the synchronous motor, the positioning is very critical. Okay, so the synchronous motor required that the synchronous speed between the rotor and stator. So there is a difference between the induction motor and the synchronous motor. Later we will see the difference between the two. Okay, and also the AC motor can be a single phase, can be a three phase, and also the control method for the single phase and the three phase are totally different. Okay, I will demonstrate to you in our later part. So for AC motor in general, AC motor can be very, very simple. Okay, you can look at your exhaust fan, for example, your toilet exhaust fan, the kitchen exhaust fan. If you open it out, right, it could be so simple. Okay, basically there is no contact between the rotor and stator. Okay, they have two separate winding. You supply the AC power into the rotor, then the rotor will induce, okay, the flux into the rotor. When the rotor being energized, they will generate the PED EMF, so-called the PED electromagnetic field, the flux. So when these two flux are repairing to each other, then of course the rotor is fixed, the position, it cannot move. So that's why the rotor has to move. So this is a working principle. It can be very simple to understand. So the advantages will be simple design, low cost, reliable operation. Reliable operation, that means if you have the very good engineering work, you have a good mechanical material, your AC motor can last for ages without a problem. Such as, for example, I still remember in my hometown, right, I own one ceiling fan that already worked for 30 years, but still can work like a champion, no issue at all. Okay, still very quiet and no issue. But in the new types of the fan, like those even the KDK or Panasonic new type of fan, right, it cannot last very long. The reason is because they already re-engineer and also recalculate the lifespan of those ceiling fan or the different kind of motor. They know that the lifespan can last for how many hours. something like a LED, like a battery, they have a certain lifespan. They calculate, so that's why all those new ceiling fan cannot last so long, especially those ceiling fan, right? That controlled by the remote control. That one even worse. After 1 year or 2 years, for sure you will need to service your control board inside, because there are some issue. I will show you the video of my repair job later on. Okay. If basically the main problem on the ceiling fan is on the bearing. Okay, if you hear the sound crack 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 on your ceiling fan, it must be due to the bearing. Okay, because the bearing is already like run the position. You cannot control the speed properly. So this is a mechanical fault. Okay? Because they already count this bearing can last for how many turn, how many years of lifespan. Okay, but the old types, they use a very pure, very good material. Okay, good stainless steel. The ball bearing is very good, so it can last for ages. Okay, variety of mounting style. That means they can develop the AC motor with a different kind of mounting available. Wall mounting, the rod mountings, ceiling mounting. So different kind of mounting is available. So it's very easy to implement. Many different environment enclosure. Enclosure means represent like a box. The junction in the industry we call it as a junction box. The junction box can be many types. Some of the junction box can be explosion proof, can be humidity proof, waterproof, different kind of the junction box or enclosure. So you can place the motor inside the enclosure. The disadvantage is the expensive speed control. Okay, why I say expensive speed control is very simple. You need to know for the AC motor, right? The speed, the rotating speed of the rotor is controlled by two things. Yeah, two things. The first thing is a poles. The pole. The pole means the winding combination inside your rotor and stator. The winding, the poles. How many poles you have? But the poles is fixed during the construction, so I cannot do anything. I make it 4 pole means always 4 pole. 8 pole means 8 poles. I cannot change the poles. One completed means it's ready. So the second parameter that control the speed is referred to the frequency. So in general, right, the speed is proportional to 120 F over P. This formula. Okay. Then the formula is the RPM. Okay. Remember this formula. So your speed, the rotor speed is proportional to the frequency and also to the poles. So that's why poles cannot be changed much, but frequency is something that we can control by using the VFD. Okay, VFD drive. VFD drive actually can be very complicated. VFD drive actually is a variable frequency drive that can change the frequency. Yeah, that one is actually under the PLC motor controller part. Okay, actually it's a VFD, variable frequency drive. It can control the frequency so that your motor can run at a different speed. This formula is applied to the AC motor. Okay, also for the synchronous motor as well. So that's why they say expensive speed control is because it is quite difficult to develop the VFD. Okay, it can be quite complicated. That's why we have a PLC microcontroller, different kind of the VFD drive. So it's expensive to design. One VFD can cost you few thousand, so it can be very expensive. Inability to operate at low speed. Okay, because the flux inside the rotor and stator, right, are based on the rotating flux. So if you are somehow is like the flux keep changing, okay, because it's rotating flux. If you want to operate at the low speed, then the flux has to be reduced. If you reduce the flux, that means you reduce the AC voltage, then definitely the motor cannot run accurately. It may stop or can run at a different speed. So it's very hard to control at a low speed for the AC motor. That's why for the low speed application, normally the people prefer to use the DC motor or DC plushless motor. Okay. Poor position control. Normally to servo form from the DC motor, so because AC are harder to control their position. Okay. So this slide show you the different. Okay. Let me see your message first. If you got any message to. Okay. Yeah, it's true. Last until warranty only. This is always happen to the latest home appliances. Okay, such as your washing machine, the refrigerator, your fans always last for a few years. Then you need to replace already. It happened to me also. My refrigerator. Even I bought the Samsung refrigerator. After just expired for 2 days, immediately the compressor made noise. Then I tried to repair. After I replaced the relay inside, it worked for another 1 month. Then it's still spoiled. At the end, it's stuck inside. Then no choice. I have to throw away my refrigerator. It cost me a few thousand. What a waste. Okay. So the compressor inside actually is a motor. Same thing. Yeah, the motor have their lifespan. That's why for the good engineer compressor, they can give you warranty up to 10 years or even up to the 12 years or 15 years. That one is with their proper calculation. Okay, of course the price is more expensive. Okay, any questions so far? Still can hear me smoothly, This one should be no problem, Okay, give me a minute, let me drink water first. Okay, give me a minute. I upload the video into the here first. Then only I can share with you. Okay, I'll upload the video. how to get back to my previous slide. Can you see this picture or not? This is my house actually. This is my kitchen. Okay, let me explain to you okay, about my repair job a bit. Okay, right. So this is the cooker hood. Okay, cooker hood actually is what the brand I forgot already. After a few years actually just 5 years so it broke down. Okay, so it totally cannot run at all. So what happened is that I have to try to open it up. The thing inside, see, you open it up, you will notice that actually this is a single phase induction motor. Okay, this one is their control board. The control board actually is to control the speed of the motor and also the lighting inside. Okay, so the transformer actually is to step down to drive the lighting and so on. There are 3 relays here. See, one relay is a speed 1, speed 2, and speed 3. Then this one is a transformer. Okay, then this is a control board. So after I do some troubleshooting, I noticed that this control board having the problem lah. Okay, it's not stable, and also it keep trip my house actually, because it may be due to some leakage problem. So what I did is that, so I have to dismantle it and dismantle their control board, and then try to figure out on this one is their board. You see, it's a transformer, their rectifier, 4 pieces of the switch. Okay, the switch actually is to control the speed. Okay, the switch 1, 2, 3, 4, speed 1, 2, 3. Okay, and this one is their controller, the pulse generator. Okay, and this one is buzzer, and then this one is the lamp, so analyzer function, and this is the output to the motor. Okay, one is neutral, the speed 1, speed 2, speed 3, which controlled by 3 relays here. So after that, I noticed that this board having the problem, so there are also maybe some burn mark happen into this board, and also it's very oily, so I lazy to repair. So what I did is that I totally remove the controller. So I just take the wires, okay, the wire from the motor. Normally the motor inside, right, there are 4 wires inside. I will explain in more detail in the later chapter about the AC motor. So I remove the wire, and then I just turn this multiple speed, okay, this induction motor into a single speed, into 1 speed, but of course make it to work at the maximum speed. So I bypass their control board. And then later on you will notice, I'll explain in more detail later on why we need to have a capacitor in the induction motor, especially the single phase. Okay, so this actually, in a lot of the cases, such as your ceiling fan, such as your compressor are not running, is most probably due to the capacitor. Okay, that's why I will explain to you about the capacitor function inside your motor system. This happened to my ceiling fan as well. Okay, this is my house ceiling fan. So one day, and I noticed that while the ceiling fan is running at the extremely low speed, it's getting lower and lower speed. Okay, this is a remote control ceiling fan. After a few years, I think 3 years, having a problem. So I need to dismantle it. This you see, inside the ceiling fan, right? This is their control board. It can be very simple. Okay, I can tell you for all kind of the remote control circuit board, it looks like this one. They for sure have 3 pieces of capacitor and another piece of capacitor at the side. So the capacitor here serves as 2 functions. One, we call it as the starting capacitor. So this one is called a starting capacitor to kickstart your induction motor. And another three is so-called the running capacitor. Okay, the running capacitor is to control your fan at the speed 1, speed 2, and speed 3. So if you notice that, right, your fan is running at the lower and lower speed, so most probably is due to the capacitor here. So what you need to do can be very simple. Just dismantle the capacitor and measure the capacitor value. If you notice that the capacitor value is lower than the rated value, then simply replace it. I can guarantee to you that your fan will work like a champion again. Okay, as long as there are no mechanical bearing issue, this is the main problem. Okay, I can very ensure to tell you that. Right. So, by the way, my general practice is that once the thing getting fault, right, normally after I repair, I will not reuse it. Then normally I will resell it in the market, in Moda or Nano, whatever. Okay, that earn some pocket money. Okay. So this is what I want to mention to you. This is my house shower. Okay, the water pump water heater. So this is what you see here, right? This is actually refer to the brush motor. Okay, it can be brush DC motor. So it's a dust. You see that, right? The inside is getting so dirty, so dirty, because the brush inside is already like a wear and tear, wear off already. So that's why if you want to buy the new one, a lot of people, if they have no idea, they will definitely go and buy the new one. So it will cost you a few hundred ringgit. The pump one can be expensive now. It can be go up to 500 or 600 ringgit. So what I need to do is you just simply go to the the Jalan Lok Yu. There are two shops that are professional in selling the brush, carbon brush. You just go there to buy the brush, then they'll show them the size that you want, then they will make it for you. Okay, the cost is just 10 ringgit, 10 ringgit only. Then you replace it, then you can work for another 10 years. So this is the brushless DC motor. One thing I want to show you here is that it's getting so dirty. See, so dirty. And the control port can be very simple also. It can be very easy to do troubleshooting. So I did have to dismantle and then clean it, and then also do some repair job. This is their temperature sensor. Normally on, okay, temperature sensor. If the temperature is getting too hot or out of the range, then you will turn off your heater. Okay. At the top here, there will be one more sensor as well. Okay. If the water is not running, then it will not turn on the sensor. There's a lot of protection inside. Yeah. So this is I'll show you the brush. This is the brush, and also this is the commutator. Commutator and brush. Okay. Alrighty. Right. How to come back to our previous slide now. Oops. Okay, class, any questions so far? Yeah, if you say save money, this one I can guarantee. Okay, I can guarantee to you. Okay, if you are good in those kind of mechanical job, right, especially electrical, you can really save a lot of money actually. Yeah, you can. For me, for my practice, right, a lot of times I learn from this. Actually, what I do is that I go search in Muda and Lelo to buy those 40. I buy the 40 TV, the 40 fan or whatever. Buy it home, and then you spend a bit money to repair it, and then you can resell it. Okay, actually sometimes you can have if you have good luck enough, right, you can earn quite a big number actually. The big black box is a capacitor. Yes, it's a capacitor. That's why I always prefer to show you on the whiteboard, because I can show you a lot of my working experience. Okay, how to do a troubleshooting kind of things. Here looks like I cannot show you much. Okay. I am not engineer, but I am considered good in technical skill. Okay? Not really good, but enough. Okay. Yeah, it's one thing. Just give my own experience now. Okay, the best thing for you to learn is that you buy those fault one, then you repair, then you sell, so that you can get some capital, and then you can buy another one, then they do repair it again. But of course, you need to have some experience. You don't simply buy, and then you are not able to repair, then you throw away as a junk. So what a waste. Especially nowadays, a lot of things can be repaired. You can save a lot. Even can tell you my house, my whole house wiring. Okay, I still remember I did my house renovation about 12-13 years ago. My house. Okay, so when the contractor come to me, they quote me the price for the wiring only. The wiring, the plug point, the installation of the ceiling fan, they quote me about 13,000. 13,000. Okay, so what happened is that I say, no need, I do it myself. I really do it myself, the entire home wiring. So I know every single wire layout, how it runs. So it involves a lot of job, not only the wiring only. Before the wiring, you need to know how to install those pipe pin, the white pipe pin, the socket, so that the pipe is concealed inside the concrete. You cannot see. Okay. Then later on, you need to learn how to pull the cable. You need to do the wiring, and also, can I have a wrong one? If wrong, the whole house will be tripped. So after my renovation, I spent about 3,000 for the entire wiring job. So you can see the contractor earn a lot of money from me. Okay, that's why I want to do it myself, because I'm quite poor, no money. That's why I do it myself. Okay, so this is what happened. When you are poor, you have to find your own way to save the money. But if you are rich enough, who cares? Just ask the people to do it, right? Or not? Okay, let's come back to the slide. I don't know where is my slide now. Any question from the floor I want to ask? Actually, you can ask me a lot of the technical stuff. Okay, how to repair the TV, how to repair those fan or those home appliances. I'm quite good in that. I wish to share with you all. Okay, so that you can actually save money from that also, and also start to slowly build all your interest on this kind of technical skill. Yeah, if I have money, I will open the workshop for you all. Okay. Except the capacitor, any other common fault? It depends. It depends on what you think you want to repair. If for aircon, it can be simple also. Aircon, it has an indoor unit and outdoor unit. Normally for outdoor unit, the fault is either your fan is not running, the compressor faulty, or the capacitor fault, or the relay fault. 4 components inside for the outdoor compressor. I can do the aircon for you if I have time actually. Yeah, and I got the firing tools. I got the gas, the burner. That do how to join the copper tube together. So all this requires some technical skill. You know how to fill in the gas, what is the pressure required. Okay. So these kind of things you learn from the small, but slowly you will build all your. The most important when you deal with those electrical stuff, you have to build out your confidence when you touch those wiring. Okay, don't simply play. You can get shocked. You don't know how to deal with it. Okay. Yep, it's true. I do a lot of part times. I can tell you that I am almost an octopus. Okay, I help people to repair and laptop once upon a time. I help people to do the home wiring. Okay, install those fan. Okay, okay, the cooker hole, kind of things, yeah. So I do a lot of things. No choice, I'm poor. Okay. I also have do the consultancy, okay, for Huawei also. So this is the process to learn. Okay? You don't stop learning. Okay? If you're good in one area, definitely someone will see your capability. Okay, I work for Huawei. Okay, you know, because for the reason because I am studying the power electronics. And then when the Huawei find me, they asked me to help them to train their staff on their data center. In the data center, there are a lot of the low power distribution, the aircon system, their cooling system, their UPS, so a lot of things inside. So this slowly helped me, from what I learned from my practical experience, I can easily learn those new knowledge and then to be the trainer for Huawei for the past 2 years. Yeah. And also other things, a lot of things can be done slowly. Okay. Okay, I asked this question from Yin Hao Yap. My house last time standing fan vibrating, not spinning, what 40? Okay, very simple. I can tell you this one is 100% due to the capacitor fault. Okay, you know why in the single phase motor, right? Your fan, right? Standing fan is a single phase induction motor. Single phase induction motor required capacitor. Why need capacitor? Because if I do not install the capacitor, there will be no turning torque. There will be a dead torque happen between the rotor and stator, but no turning torque. So that means the force between the rotor and stator are perpendicular to each other. So they will not be able to generate the turning torque. So they will just vibrate, up and down vibrate. So that's why we need to install the capacitor to generate the net rotating torque for your motor. This is the purpose of the capacitor inside. Okay, believe me, you just go and replace the black color one capacitor inside, then you can work like a champion. Okay, no problem. You can manually kickstart if you can turn the blade up to the 1000 RPM. It must be able to reach up to the 80% of the speed, then only you can continue to turn. Yeah, the sound also refer to the capacitor 40. If after you change capacitor still not work, it's due to the bearing problem, or maybe you turn on the fan for too long, then the coil, the winding inside is already get burned. Okay, the rotor get burned already, that one cannot have lah. Okay. Because when the fan cannot turn right, they will drain a lot of the current. Then it will getting very hot. Then if you still not rectify the problem, then it will burn the coil, okay, the rotor inside. The one called motor burn. When motor is burnt, then no cure already, can throw away already. Okay, we have to stop talking on this one first. Let's come back to our slide first. I have a lot of things to share with you lah. I wish to share with you. Okay, believe me, I like to share with you all. Okay, so that as long as you want to learn. Okay, let's come back to our discussion again. Just to ensure my mic is turned on. Okay. Still, this slide shows you the differences between the AC motor and the DC motor. Okay, so AC motor are powered from AC current. Okay, means AC source. The DC motor is a DC source. In AC motor, conversion of current is not required. That means you do not need to convert from AC to DC. But this motor, you need to use a rectifier or to convert from AC to DC. The AC motor are used where the power performance is short for extended period of time. Normally, AC motor, right, is for the long operation requirement. Okay, because basically AC motor, they do not have the contact between the rotor and stator. As long as your bearing is good, so basically they will not generate much heat from the operation. So it can last for long period of operation. But for the DC motor, they may not be encourageable if you are using the brush DC motor, because the brush DC motor have a wear and tear issue unless you are using the Hall effect sensor, the brushless DC motor. Okay. The DC motor are used where the motor speed required to be controlled externally. Basically, you need to control the voltage. Okay? Control the voltage or from the external circuit. Normally, it's the device that controlling their fire angle or degree cycle. AC motor can be single phase or three phase. All DC motor are single phase. This one I doubt is true or false, because I also see some DC motor that utilizes three phase as an input. But maybe that one is referred to the synchronous motor. I have to check on this one. Okay. In the AC motor, armature do not rotate while the magnetic field continues to rotate. The reason is that because armature means their rotor side, okay, but then they producing the rotating flux, so the flux keep rotating because they keep changing the pole 1, P1, P2, P3, 4 keep changing the flux, so they will generate the rotating flux. But for the DC motor, the armature rotate while the magnetic field does not rotate. Magnetic field is generated from the magnet, so the magnet having the fixed flux, so which is not rotatable. Even though you use the excited DC motor, the flux also not rotatable. Okay, are fixed. Repairing the AC motor is not costly. Okay, this is about the motor, not the controller. The controller can be very costly, but the motor itself is not costly because it's just like a winding inside. The rotor winding and the stator winding and the bearing. If the bearing is good, yeah, basically the cost of repair is not so expensive, and it's easy to repair because very easy to dismantle. Yeah, you can easily dismantle your exhaust fan or ceiling fan. Very easy one. Just unscrew the 4 nut at the top at the one end. Then you can remove the rotor from the assembly. For the DC motor, repairing cost is higher. Okay, especially because it's normally it cannot be removed. Okay, so the cost to repair the armature is higher. AC motor does not use the brush. Okay, this one I need to clarify a bit. AC motor does not need to use brush. This one is referred to the induction motor only. Induction only. If you're talking about the synchronous motor sometimes they will use the brush as well, even though you are using the AC motor. Okay, the AC synchronous motor sometimes they use a brush, so this is not totally correct. So, but you have to make it clear. For brush, for the induction motor, yes, they don't use brush, but the synchronous motor sometimes yes. DC motor use brush. This is also not really true. because this DC motor, only the PM, permanent magnet DC motor, utilize the brush. For the Hall effect, okay, Hall effect sensor motor, no brush is required. Okay, so you have to make it clear on this one. An AC motor have a longer lifespan. Yeah, it's true, because there is no wear and tear issue, and also as long as bearing is good, as long as your winding is good, then it can last for 20-30 years without a problem. Okay, DC motor have a not long lifespan. It depends also, it depends on whether it's a Hall effect or it's a brush motor. The speed of AC motor is simply controlled by varying the frequency of the current. Yeah, it's correct. It's a frequency control. Okay, for the AC motor. For the DC, the speed of the DC motor is controlled by varying the armature winding. Actually, it's a voltage, not really current. They miss out the current and voltage. The speed is controlled by the voltage. Yeah, so it should be voltage, right? And then for the AC motor, required effective starting equipments like a capacitor. So it's a part of the starting kit. Starting kit actually is the starting mechanism that enable your AC motor to start turning. But also, please make it clear that this capacitor only used in the single phase AC. Okay, only in the single phase AC. Capacitor is not required in the three-phase AC, because by nature the three-phase AC already has the rotating flux inside their phase 1, phase 2, phase 3. Okay, remember, I will ask you this question maybe in the final assessment. Why we need the capacitor in the single phase but not in the three-phase? All right. Okay, time for a question. Any question on us? Okay, can repeat why three-phase no need capacitor? It's very simple. That's why if I have a whiteboard, I can demonstrate to you very easily. I can show you the full diagram. Okay, never mind. I just show you orally. Okay. In the three-phase, you know three-phase, right? You have the phase VA, VB, VC, right? Remember, you have delta and Y configuration, right? The three-phase. Each of the phase in the three-phase are separated by 120 degrees. 120 degrees. So, by nature, they already have the phase difference between one phase to another phase. So that means by nature, they already have a phase difference that can generate the rotating flux, so-called the rotating torques. That's why in the three-phase motor, no need capacitor. If you don't believe, you go outside and try to look for aircon. If you manage to find any aircon system, right, that running on the three-phase, especially those 4 horsepower or 5 horsepower aircon like a compressor, I guarantee you cannot find capacitor inside. Okay, because all three-phase motor, no capacitor is required. Okay, starting capacitor only need to be used in the single phase. Okay, in Malaysia normally you use Y configuration standard one Y configuration. Delta, our transformer are Y configuration. So each one are separated by 120 degrees. Running capacitor, that one is only happen to the remote control ceiling fan. Okay, inside the remote control ceiling fan, there are two types of capacitor. One is a starting capacitor. Another one is the running capacitor. The running capacitor has three pieces that run on the speed 1, speed 2, and speed 3. Okay, if you don't believe, right, you can change your old type ceiling fan that use only one capacitor one. You try to use the bigger capacitor value. I can guarantee to you that the speed can be faster. It work like a Superman, I tell you. Okay, you can run very fast if you use a bigger capacitor value. Okay. Now it's chit chat time, not yet. Now you go to the slide. Okay. So remember that, okay, we only use capacitor in the single phase, not three phase, because three phase by nature do not have any rotating torque. That's why we need to have a capacitor to generate the phase difference between the main supply, so that the rotating torque can start to turn the motor. That's why in some of the machine, right, you can see the so-called the centrifugal switch kind of things inside. You type the keyword in Google, centrifugal switch. This is also one of the component in the motor control. Normally, 220 watts, they have a tolerance about plus minus 10%. So 220 watt, it can be used in Malaysia. Okay, no problem. Alright, I come back to our slide first. Okay, as last part for today, okay, I will explain to you the criteria for selecting the drive component. That means when I want to choose the motor, I need to pair with the controller so that the controller can provide the optimum performance to the motor, so the motor can run effectively. So this one we call it as a criteria for selecting the drive component. Okay. When you look at this circuit diagram, okay, this is a standard for the motor controller loop. Okay, the controller is referred to the. Actually, it's very simple. If you refer to electronic circuit, right, this is the summing point, like this. It's a plus. Normally, the bottom one is negative. It's a negative feedback. So it's an input within. Then this is output. Here is the ER. ER means the error signal. Go in. The error signal, they can control the the power electronic converter to turn on off, okay, at a certain duty cycle, so that the sufficient energy can be supplied to the motor. When the motor receives the voltage, okay, the average voltage, then the voltage is proportional to the speed. Then you can control the speed. Later on, if you want to have a higher torque, okay, especially when the load is increasing, you're installing the heavy load on it. So the heavy load requires the higher torque. The higher torque require higher current. So require higher current, then I need to supply the higher current to the motor so that it can turn the load at a constant speed. So there are a lot of the control inside. And the output here, normally they will install with a different kind of sensor. Okay, the speed sensor, the position sensor, tachometer, and then this sensor will sense the speed, sense the position, then it will feedback to your controller through this summing point or summing amplifier. So when you want to design the motor, there are a lot of consideration, such as to match between the motor and the load. Yeah, this one is very important. Yeah, it can be very simple. For example, right, I cannot use the conceal engine to put inside my Alphard, Toyota Alphard. Otherwise, my car cannot move like a turtle, or it will overload my engine. Then after a while, the engine will get burned. So this is you cannot overload your motor. The same thing happened to also. If I use the conceal, okay, the small CC car to drive up to the Cameron Highland or Gurney Highland, I noticed that the engine will get very hot. Okay, this is the reason that the motor will work under load condition. Will work overload condition. Overload means there's not enough power to supply to your shaft, the drive shaft. But then they still try to push. You still keep pressing on the pedal. So you keep pressing on the pedal, then they will drain more current. They will drain more petrol. That's why if you drive your country up to the Gurney Highland, they will drain a lot of the petrol because the engine is overloaded. Then the piston have to keep working much faster speed, higher RPM, and so they will consume more petrol. But if I drive the other car like a Civic or Toyota Camry, okay, to drive up to the Gurney Highland, in this case, I will not overburden the engine because the Camry have a 2.0 liter of the engine, which is much more capable to drive up the hill. So in this case, your car petrol consumption will not consume so much compared to the conceal case just now. So you need to know how to measure between your load requirement and the motor. And the thermal consideration in selecting the motor. Okay, thermal, right, is very simple. Thermal is generated when you have a high heat generation. Okay, the high heat generation will happen if you drain a lot of current. Simple. Can you get my idea? Current is energy. If you use a lot of current, that means they will generate a lot of the heat. If you generate a lot of heat, then the temperature will rise up very, very, very fast. That's why your engine will get burned. The gasket will get burned. Overheat will burn your entire car engine because you are drained too much of the energy. The torque is overloaded. Torque is too high. Okay, so the torque is proportional to the current, and also is proportional to the temperature. Yes. So this is the relation between one and each other. And then the match between the motor and the power electronic converter. Of course, when you buy the 1 kilowatts motor, you can use the 500 watts controller. Otherwise, your controller will be overload. Then it can get burned very easily because it drains too much of current. Then it will not be able to handle. Then it will get burned. Yeah. Selection of the speed and the position sensor. So this is about the feedback system, the feedback from here. How to install the controller, the sensor on the output to know their operating status. Servo drive control and the current limiting. Current limiting is a must in the motor controller. Okay, this is exactly This exactly happened to my electric car. Okay. Still remember I told you before that I own one EV in Utah. Actually, I developed one EV in Utah. Okay, using the bottom vira. I convert the bottom vira, and then I remove the engine. I remove their petrol tank. Then I plug in the induction motor, the 3-phase induction motor. Then I use the 3-phase controller and use the 144 watts DC input from the 12 pieces of battery. Okay, what happened is that one day, right, I drive my EV out into the town. Okay, go out to the highway. When I drive my EV at about 80 km per hour at time, very I think no, it's about 100 km per hour, very high speed at time, right? It suddenly the speed, the speed will drop a lot. Suddenly it dropped, and then the whole car become no power. That means even though you keep pressing the pedal, right, the car something like cannot move. It move with a very low power, low torque. Okay, the reason is because that time, the first time I test run my EV, right, I forgot to install the cooling pad, the cooling heat sink on the EV controller. It caused the controller to be overheated. When it overheated, it will turn on their current limiting circuit. Yeah, this current limiting. When they turn on the current limiting circuit, that means you are limiting the current that can supply to your motor. That's why now you will feel like your car has no energy, no power. Even though you keep pressing the pedal, the car cannot run. So this is the reason of the current limiting circuit. So after that, I have to drive my car, put at the side road, wait for the half an hour until the system cool down, then it can work back to normal. Then later on, I know the reason. It's because of the overheat issue. So this is the way we learn. Okay. Right, this one is show you the profile, yeah, the mesh between the motor and the load. So it depends. Normally when you are designing some motor function, normally you need to know their profile. For example, you are carrying some goods on a conveyor, for example. So you know what is the profile I need. Okay, first I need to accelerate the speed. Okay, so here is acceleration. Then later on here is a constant speed. Maybe I carry the load with a constant speed. And then this one is to stop the engine or stop the conveyor, for example. So this is the profile. So based on this profile, from there I will see what is the load torque I need. Torque is required to start the engine or the motor. So the speed can speed up the torque. So when I run it at the constant speed, normally the torque is 0. No, the torque is required. Okay. Remember, at the constant speed, the torque is 0. And later on, here it may be due to the negative torque. Maybe I press the brake, which is to stop the motor. So something like this. So this is about the profile. You need to know the profile if you really want to design the good optimized motor controller. So when you select the motor, right, it also depends on how you do the coupling between the motor and also the gear ratio. Okay, so it can be direct coupling. The direct coupling is example for your drilling machine. Right? When you drill the hole, the wall, right? The drilling machine, where you want to install the plug socket, you want to install the lighting, you want to install the ceiling fan, you need to drill the wall, drill the ceiling. So the drilling machine is so-called the direct coupling. They do not have the gear ratio inside. Okay, and then the one with the gear mechanism is something like a belt and pulley, such as your car, right? Your car, you have the compressor, okay? You have the alternator, right? You have the aircon compressor. So all this actually is driven by the belt and the pulley. Belt and pulley to drive your compressor, to drive your power steering. Okay. Rod and pinion is the one also used inside your car. Okay. You see the next slide, right? This is the rod and pinion. Actually, when you turn your car steering, right? You turn your car steering, you are actually controlling the rod and pinion, the gear of this one. Okay, so that your car can turn to the left and move to the right. Okay, the rod and pinion concept. So a lot of people claim that after the year been used for 10 years, when the steering wheel will turn, will have a sound. Okay, you have a so-called a sound on your car steering when you turn left and right. This is the issue. Is due to the rubber inside. Okay, the rubber is been wear off. Okay, rubber is getting fragile already. So you need to open up the steering and replace their gear, whether got any wear and tear issue or not, and then replace some of their mounting and also their rubber joint inside. Okay, whole this process may cost you about 800 ringgit on the whole process for the car. Okay, I've also got experience about this one also. Okay, and this one is about the rod and pinion. Yeah, belt and pulley. Belt and pulley is something like your car aircon's compressor, your alternator. Yeah, all are driven by this kind of belt. So you will see a lot of belt. It's not timing belt, it's a belt. Okay, to drive your compressor and alternator. Alternator is the one that generates the AC to charge back to your battery. Okay, for this one, it's very simple. When you come to the thermal consideration, right, it's very simple. Thermal is proportional to the torque, and torque is proportional to the current. You see, they will have exactly the same profile. If I want to increase the torque, I need to increase the current. If I increase the current, the temperature may rise up. So you need to see the temperature profile, see whether they hit the upper threshold or lower threshold or not. Okay, so this is the profile. Okay, the torque is proportional to the current. So the total loss can be different kind of the loss, can be the bearing loss, can be the load torque loss, a lot of losses, but this one is not so important here. Okay, any question? So this is about EV. Okay, if you want to learn about EV, also can explain to you about EV as well. We still have one EV in the Utah campus, okay, in the basement. But at the moment, the EV are not in the running condition because the battery is died off already. After 7 years, it's died off already. So unless you want to invest 10,000 on my project, then you can make the battery work again. Yep, we need to get a permission from the JPJ. I drove to the JPJ office in Putrajaya once upon a time. Okay, I drove there and then let them to inspect my EV. Okay, so they give a lot of comment so that your battery cannot put inside the car. You need to put the high voltage sign on your motor. A lot of the people kind of things. So this is all the experience I have. Okay. The range of the EV depends on your battery capacity. Yeah. The EV that I owned last time can drive up to about 80 to 100 kilometers. Depends whether you go uphill or downhill or on the flat road. Okay. I think 80 kilometers is good enough for the daily use. Okay. It can be very powerful. Okay, my EV can be very powerful because I use a very high torque induction motor. Okay, even my car can drive. Okay. Unfortunately, I cannot show you now because the battery are totally gone. Okay, cannot be used anymore. Tesla, yeah, if you give me a same amount of money, I can develop one for you. Tesla, they use a very high efficiency motor. They can do the regenerative braking. They use the lithium battery pad. Okay? They use 300 over pieces of the lithium battery underneath their car seat, like an battery array. So the lithium battery is very expensive. Okay, that's why you see the Tesla Model S, Model 3 are so expensive. Okay, that's why it's even without tax also a few hundred thousands USD. So that's why very expensive. Not to say about the technology, but about the development cost also very expensive. Okay, I move to the last part. Okay. So the next part is about mesh between the motor and the power electronics converter. This is what I mentioned just now, right? You need to know what is the capability of your power electronic converter, so that the proper mesh between the motor and the controller can be realized. Okay, when especially the motor is running at the high torque condition, make sure your controller are capable to supply the sufficient current to your motor. That's why you see a lot of the cases where I do the consultancy work, right, to the industry. So in most of the case, when the motor is stop running, it's because of their controller. Okay, sometimes they want to buy the cheap controller. So when you buy the cheap controller, the performance is always not tally with the specification they put on the label. Okay, so it cause the controller to get burned. So it's always happen in the industry, because normally in the industry, they do not want to put too much of the initial investment on their initial design. So they will cause a lot of problem also after a while of using. So you need to consider about their current rating, the voltage rating, the switching frequency, and the motor inductance as well. Motor inductance means the internal inductance, because you know that, right? The motor is also the inductor, because it's a winding. Okay, motor inside is a winding. They have the inductive effect. You also can control the operating mode, continuous and discontinuous mode as well. So see, the current rating is proportional. This is a good example, okay, to show you the relationship between the torque, the temperature, and the current. Yeah, each of them are proportional to each other. The voltage rating, voltage rating means in both AC and DC motor, the motor produce counter EMF. That means the back EMF that oppose to the voltage applied. So the rate of motor current, see, when you supply the energy to the motor winding will be energized. When they energize, they work like energy storage. They will produce the back EMF, so like back voltage. So in order for the motor to carry the current, your source voltage must be larger than the motor voltage. This refer to the voltage difference. Okay, voltage difference will make the current to run inside your motor. Okay, and then the switching frequency and also the motor inductance. This is the good relationship. The purpose of you increasing the frequency, right? As I mentioned before, sometimes the ripple can be very high. Okay, the ripple in the motor current can be reduced by increasing the converter switching frequency. Simple to say, we have two ways to control the switching frequency, to control the ripple, get the ripple current. One is you increase the inductor value. Okay, you increase the inductor value, but normally we have a certain limit of the usable inductor value, because the cost for the copper winding can be very expensive. So normally we don't increase the inductor value to be so high. Otherwise, the cost for the winding is very expensive. The second method is that we can actually increase the operating frequency. Okay, if you increase the operating frequency, then it will on off very fast. So the inductor will not have enough time to discharge, so they can produce a very small ripple. Okay, that means if the switching time is very fast, the ripple will become very small and very compact, very small. Okay, so if you view the output ripple in general, you just see like a straight line, a DC with a small ripple inside. However, there are some limitation on the switching frequency. Okay, because if we increase the frequency, they will experience the switching loss, as mentioned before, right? Switching loss, the turn on and the turn off loss. Switch on, off, on, off. So the loss will be high. So that's why we have a limited usable frequency, typically limited to about 200 or 300 kilohertz at the moment. We cannot have too high frequency, otherwise this loss will be too critical. Okay, so you need to find a mesh, the mesh between the emitter value and the switching frequency. So the last part is about the current limiting. Current limiting is a must in most of the circuit, okay, to limit the current that can be handled by your controller. Okay, the purpose of this actually is to protect your controller lah. Okay, I forgot to mention just now. Okay, it happened to me before about my EV. Actually my EV. I don't know what happened. Okay, I believe it's due to the loose contact on the battery connection. Okay, so when you have a loose contact, actually this one can be very severe, very serious. Okay, when you do the wiring, when you do the any connection, right? Make sure you tighten all the connection, especially when you deal with the high voltage and high current. The reason is that, remember, right? My EV utilized 12 pieces of the 12 watt battery to top up to 144 volts. So when you turn on the controller, so the both positive and negative end, right, will experience the highest pressure. And then it happened that at the positive terminal there, right, the connection getting loosened, is loose connection, so it has some small vibration. When it vibrate, right, it will generate the high spark. When it vibrates, something like it works like a switch, so it will vibrate. It will generate the high spark up. Okay, the high when it's turned on like this, right? For example, it will high spark like this. The spark. This spark eventually kill my controller. Okay, kill my controller. I drove. Luckily, it's not me driving the car at the time. It's my student actually. He drove the car outside the Utah campus. Actually, outside the Swalong campus at night. I did. Okay, 8 o'clock. When he drive there, suddenly he hear the very high explosion happen on the battery terminal, because when they vibrate, right, it actually generate the high spark, and then it cause explosion, okay, on the battery terminal. Then this when it explode, they will propagate the high spark, high transient into my controller. Then it burn my controller. It totally burned my controller. The smoke came out from the bonnet. Okay, luckily that time my controller is on the last day of the warranty period. The last day. Tomorrow, no more warranty. So it's the last day of the warranty period. So I quickly contact the controller supplier from US side. Okay, and then luckily they willing to replace with a new one for me. Okay, the cost of the controller is 2,000 USD. Okay. No. Sorry, it's not 2,000. It's almost 4,000 USD. The controller itself. It's a high power controller. Okay, almost 4,000 USD. Okay, so they have to have a current limited circuit to limit the current, so that your controller can be protected. My EV controller gets spoiled because they do not have a sufficient protection against the transient. Okay, sometimes like a transient, like lightning strike. In most of the case, we cannot protect against the lightning strike, the direct lightning strike, okay? Because the transient is too high, the amplitude is too high. Okay? So this is the case. Okay, so I think I will end my lecture here, stop here, and then next week I'll continue with the DC drive to teach you how to control the duty cycle, how to control the fire angle, so that you can generate the appropriate DC voltage or current to your DC drive. Okay, time for last question. Any question you want to ask? Junction temperature is referred to your controller temperature. Make it simple. Junction means their terminal temperature. Okay, again, yes, no final. It will be replaced with the so-called final assessment, not in the final exam form, and only contribute 40%. In other words, the mark for the midterm test, the mark for the assignment, the mark for the lab will be jacked up to 60%. So now you still have chance for your assignment, you still have chance for your lab, so make sure do it properly. Next week count as week 10, yes. New so-called new week 10, new week 10, not the old week 10. If all will be week 12 already, but we can turn back to week 10 because of this movement control. So midterm test contribute to 30 mark. Times 1.5. 20 times 1.5 is 30. Everything times 1.5 for the coursework. For those who haven't go to the practical, right? You please refer to my video and also the so-called the mock result I upload in the Weber. Use that result to write the report because the lab 2 is very simple and very small part that require you to do the lab experiment. Only the first part you need to construct the circuit and get the result. So in the Weber, I already upload the result for the part 1. The part 2, they will no need to do. Only need to explain the working principle. Midterm test now currently is with Dr. Chong. I cannot find him. I cannot meet him, so I cannot get back the paper to mark. So I need to wait until the MCO is over. Then I can get back the exam paper that I can mark and let you know the final result. Okay. Dr. Chong may already finish the marking, but I cannot get the paper from him, so I cannot mark. So, but to be honest, I will mark this time to be very lenient. As long as you do. Okay, come back to your battery voltage, right? How many of you put the wrong voltage? Car voltage also don't know what's the voltage. I think you never touch about the car or whatever. Okay. Okay, I know some of you make it wrong. Okay, honestly, the correct one should be the actual one should be 12.6 watt. The car cannot use 240 watts, man. Okay, to be more exact is 12.6 watt, but to be more general, the people simply say 12 watts is okay. Okay, 12 watts is okay. So I know that a lot of you cannot do it. This is my purpose also. Okay, my purpose to don't tell you the car voltage, because if you make it wrong this time, you will remember it forever. So next time when I ask you what's the car voltage, you can immediately tell me without hesitation, 12 watt. Okay, so because this is the first time you may really do not know about the car, and then I will not penalize you because of the wrong voltage. Okay, I will mark based on your input voltage to apply on your converter. As long as you're able to get the output voltage, fine. Can agree? Happy? Satisfied? This is my purpose. This is my purpose. I saw my lesson to you all. I want you to remember forever. 12 watts, okay? If next time happen again, say in other assessment, you give me a wrong voltage, they want to give you 0 mark already. No more excuse. For EV, there are many voltage rating requirement. Okay, it can be as low as 48 watt. It can be as low as 96 watt, like a Nissan Leaf, or it can be 144 watt or 272, 240 watt. There are many voltage range available. Okay, depending on how you do the configuration. Tesla, inside they don't have a normal battery. Okay, normally for EV, right, there will be one normal battery inside because they need to give the supply voltage to your controller, so that your controller, like a brain, your brain, to start activate. Okay, so normally there will be one backup battery inside the EV to power your controller, to power your system. Okay, if there is no battery, then the system doesn't work, then you cannot turn on the controller. Engine is hybrid. Okay, now there are many types of the vehicle in the market. We have a ICE car, internal combustion engine. Okay, internal combustion engine, which is the petrol car, diesel car. We have the hybrid car. Hybrid car means combination between the engine and also the battery. Okay, but for the hybrid, the battery only work as an assistant to the engine. When you drive on the highway, so they will switch to the battery mode kind of things. Okay, it's optimization. And then we have the hybrid. They have the plug-in EV. Like you plug in the charger port into the battery car to charge the battery. They will call a pure EV. So there are many types available. So for the coursework, all the components will be multiplied by 1 by 5. Okay, it's correct. That means lab 1 by 5 become 15 marks. Assignment multiply 1 by 5 become 15 marks. And then the midterm test 20 marks times 1 by 5 become 30 marks. Total 60 marks. Another 40 marks from your final assessment. Final assessment is the faculty still configuring. Okay, so there may be a few forms, maybe another kind of individual assignment, or maybe online quiz, or we still finding a way to do it. Okay, but that one will contribute 40%. Okay, but for sure, no more final exam and no more face-to-face. Okay, that's all, and enjoy your dinner. Okay, then don't forget to do exercise. Exercise indoor. Don't go outside, otherwise the police will chase you home. Take care of yourself, and make sure don't get sick.
Okay, sir.